Okay, let's start. Fine. So last time I think what we have seen is we have looked at inheritance, right? And we saw about inheritance, and there we have what we have used. Yes, we have created, initially we created a class called rectangle, fine, and then created a subclass of rectangle called void. Yeah. So how was the experience of using cuboid as a subclass of rectangle? Created some problems? No. Well, it's not a good case of inheritance. Fine. See why? Because if someone says this is a relation is not correct, fine, is not good. Fine. What kind of relation is between rectangle and cuboid? It's not is a relation, right? Cuboid is a rectangle? No. Then what? What kind of relation? What is the kind of relation between them? It's a has a relation. If I say cuboid has a rectangle and height, that sounds good, right? And so relation between cuboid and rectangle is not is a, it is has a relation, fine. So this is nothing but it's a case of, so we have has a relation which is good, fine. Okay, and so the relation is has a relation. Has a signifies composition, and we should go for composition rather than going for inheritance, fine. Unless you have a case of is a, do not go for inheritance, fine. It's always better to go for composition, fine. Fine, it's much better. We'll see. There's so many advantages of using composition, right? When you create a subclass, what happens? Yeah, everything is inherited, whether needed or not. You get this. Fine, you don't have control over what should be there. Fine, the superclass adds a new method. Okay, that's available to you also. Fine. See, these are classes. Classes are data types. They are nothing but they have to be very consistent kind of things. They can't be just anything. You have to think, okay, if this type, this is what I'll provide. Fine, what you want to provide for your data type has to be very carefully thought about. Okay, fine. Therefore, you shouldn't just say, okay, oh, if there is something extra, it's okay for me. Fine, it's not that way. Every method, what is it that is available for your type should be under your control. Composition gives you a good control of what you want. With composition, you get control on what you want. Exactly, these are the methods I want, and that's what I'll have. Fine, let's see. So the same problem, how do we solve if we had to go for? Fine, it's not a is a relation, it is a has a relation, which means go for composition. Fine. In case of composition, how we could have done this? Yeah, we have the class called. So let's redefine the cuboid class. Oh, we have fine. Earlier we had defined class cuboid as a subclass of rectangle. No extends now. It's class cuboid. Fine. Cuboid is cuboid. It's not something. Okay. Fine. But when we say composition, cuboid has a rectangle and height. Fine. So yes, some you might think about reusing. There are so many things in rectangle, I would like to reuse them. Of course, you can reuse even with composition. Fine. It's only slight effort. It's not very big effort here. Fine. But you decide what you want. Fine. It's not the superclass deciding for you what you will have. Okay. Fine. So we'll say, okay, this has a rectangle. So we can say, okay, there's one variable of type rectangle. Let's call this variable as rectangle. Fine. It has a height. Okay. So it has integer height. Fine. So this is composition relation. Yeah. What's next? Want a constructor with 3 parameters. Okay. We have a constructor for cuboid which would require 3 parameters, a int for the length, another integer for the height, another integer for the, sorry, this can be width, second can be width, the third can be the height. Okay. Fine. So what goes in this constructor? What should be done? Initialize the instance variable. What's the first instance variable? What's the first instance variable? Rectangle. So let's initialize rectangle. We'll say this dot rectangle equals, yeah, new. Fine. You need an object, new rectangle. In the constructor, use the length and the width. Fine. Uses length and width, and we have this dot height equals height. Fine. Okay, there may be a complex method available in rectangle. Some very complex calculation may have been there. Let's assume like we have a area method may have been very complicated. Oh, whether we need area for cuboid? Okay, we don't need. Fine, we don't get it. We decide. Fine. Okay, we can decide. But there might be some very complex method, let's say, which is available in rectangle, and that is the same one which you want here. See what you would have what would have happened in case of inheritance. Exactly same thing. Some complex method. Let me assume there is a complex method in a superclass. Fine. So if you have that complex method, fine. Maybe the complex method has return type void. Okay, I'm just putting, fine, just to demonstrate that yes, composition also has reuse. You get reuse even with composition. Fine. So if I had something, yeah, okay, some complex method from superclass. Okay, maybe it has some parameters, whatever. What do we do in order to reuse? This is something I'm assuming is available in rectangle, suppose. Fine, this is something which is available in a rectangle, because if you start making comparisons, say, okay, I can reuse. Fine, I don't have to rewrite. Here, what would you do? Yeah? You can simply say this dot rectangle dot complex method. Just pass it on. There's no complexity here. It's the same thing what was available in rectangle is being used here. You just have to redirect to that object. Any method, right? Fine, you don't have to recode the whole thing. It's just a question of redirecting to the object which you have. And see composition, better control, right? You decide exactly what you want for your class. Fine. Okay, so maybe you had those methods like get length, get width. We didn't add those. You could have added those methods for your exercise, fine. Methods like get length, get width, get height, okay. So yeah, how do they work in this case? Get length, get width. How will they work? Get length and get width. Return this dot rectangle dot length. Okay. Yeah, and dot get length. Reuse the get length method. Reuse. Fine. Normally we would not access the variables directly. Okay. We should be using the methods. Okay. Fine. We'll soon be coming to that. Access specifiers. What are the access specifiers and other things? We'll come to those things. But yeah. Okay. So that's a constructor. Then we have a method. Yeah. What kind of method we can have? What methods you want to have for your cuboid? Yeah. Volume is now simple. Fine, you can add int volume. Fine, this can be written very simple. Return this dot rectangle dot area into this dot height. There is no question of overriding. There is no superclass. And we don't have to worry about that. Okay, what else? Get length, get width, get height. Set dimensions. See, set dimensions with two parameters in cuboid doesn't make sense. But you were getting those methods. Fine, for cuboid, a set dimension would say, okay, 3 parameters, not 2 parameters. But you were inheriting it. Doesn't look good, right? You can have set dimensions now. Yeah. Void set dimensions. And you have those 3 parameters. You know how to write this now. This dot rectangle set dimensions, use the 2 parameters and initialize the height. Composition over inheritance. Always prefer composition over inheritance. And we always would prefer composition over inheritance. And unless we have is a relation, pure is a relation, do not go for inheritance. Okay? Fine. Is this thing clear now? Inheritance and composition. Fine, we can finish the new version of cuboid also, right? With this. And required methods. No use of super. You don't have super class. There won't be any super anywhere. Okay. Right? Okay. Clear. So other than is a, we have has a, those kind of relations. Fine. So be aware of this. And so always, don't always go for inheritance. No. Because something is to be reused. Inheritance is not the answer. Okay, now the next thing which we have is like this. Okay, and this you can finish, but that's fine. Now the next thing is we had defined cuboid as a subclass of rectangle earlier. That's one version of cuboid. We have cuboid which is used for composition, another version of cuboid. Fine. There are 2 different classes, 2 different definitions for the cuboid class. And I want an application to use both the cuboids. I want to write an application where I can use both the cuboid. How can it be done? And in both cases, the name of the class is cuboid. What do we do? Huh? No, not yet. No, but the name of the I have two classes. They both have the same name. The name is cuboid. The name is cuboid. I want two such classes. What do we do? I'll give another example. Fine. In Java, we have seen there is a class called string. Fine, we have a class called string. We have used that class. Fine. Someone is writing maybe a tailoring application and he says, okay, oh, I also have a class called string. I want to have a class called string. You want to write your application and then you'll say, oh, I need to have my own class called system. Same name of the class, right? I want to have my own class. I want to have the same name still. How can I use both of them? Can we use? Extend one of the keyword and create. You're not getting the question. The question is, you got two classes by the name of cuboid. You want to manage two classes having the same name. Can we have two classes with the same name? Can we have two classes with the same name? Yes or no? Yes. Well, in your class, in college, you have two students with the same name. No? नहीं है नहीं है नेम मैच नहीं कर रहा है किसी का भी है so what do we do हैं नेम मैच करेगा तो क्या करेंगे surname suppose surname also matches then huh place कहाँ से आता है you will have a mechanism to make it unique. The name is still the same, okay? You don't have to change the name. You put some prefix. You add some prefix by which you're saying, okay, oh, that's my full name. That's a full name, though locally I can call him, I can call it cuboid, right? But you have a full name. There's a full name associated with everything which you defined. And so when you define a class, if you want, you can give a prefix to your class name. So for example, here for cuboid, I'll say, oh, I have a cuboid with inheritance, I have a cuboid with composition. So I'll say composition.cuboid, inheritance.cuboid. Fine. Oh, there's a string. Oh, that's the string which is the Java language string. So I can use java.lang.string. Oh, that's one string. Fine. See, people will be developing different classes are being created in object-oriented programming. We understand that yes, we are going to be developing a lot of classes, and these classes are being developed independently by individuals Fine, all over the places, different organizations are developing them, and there is all the possibility of same class names occurring everywhere. Fine, so many times you'll have that. Right? So there are some conventions which are also being followed, because the thing is, when you start writing your application, you'll say, oh, I need to use that library that's been provided by someone else. I also need the another library. I'm using 3-4 different libraries in my application, right? And all those 3-4 different libraries, they are coming from different suppliers, right? I've got them from different places, and they contain the same class name. Fine. So, we should have a prefix by which I can identify from where it comes. Okay. So the normal convention. So just to demonstrate what kind of conventions are followed, right? Because lot of things are open source. Fine. So the kind of conventions which are normally followed, just to demonstrate that, I'll give an example of a fully qualified class name. Okay, see this prefix which I am talking about here. This is a prefix for the class called string, and we call it as, in Java we have a term called package. Right? Package is nothing but a prefix which you put for your type, class, interface, enum or annotation, whatever you may be defining. You can put a prefix to make the name unique. Okay, fine. To show that example, what conventions are followed, fine. For example, we have a company called Apache. Okay, they have developed some framework called struts, which has a module called action, where there is a class called action. What they do is, yes, because anything which comes from Apache, if anything is supplied by Apache, they would always have a prefix. It is apache.org, that's a website. So they'll say, okay, for us, it's like our package name. Fine. Now I'm talking about package name, the prefix part, not the name of the type, fine, but the prefix for your type. The prefix can be, so it says org.apache because it is apache.org. org.apache. Fine. Within Apache, there are so many different products which they develop. So this is one framework called struts. Okay, struts. Within the struts framework, they have a module. One of the module called action. And within that, yes, and I now come to a class called action. So all this part is nothing but your prefix, or we call it as package. Purpose, to make it unique. Okay, so how do we do this? Okay, so coming back to the syntax part, you have a Java file. Fine. In a Java file, we know we can define 4 items: class, interface, enum or annotation. Okay. Now all 4 items can have a prefix. Fine. You want to have some prefix for them. So if you want to have a prefix, declare in the file. It has to be declared right at the beginning itself. Fine. So in the beginning, in my file, I'll declare, okay, fine, for anything. For example, I'll say, okay, package. I'm relating to maybe we have com dot class of Java. Okay, fine. In class of Java, we have Java 1702 uniquely identifies us. Fine, this batch, and they are developing things related to inheritance, INHER, I'm making it shorter, okay, inheritance, fine. So things related to inheritance, maybe I'm putting it here. Fine, you can decide what prefix you want. So this is a prefix for anything which I am writing here. Fine, or maybe I don't want to specify anything about inheritance, I can stop here also. I can say just this much. And so that's a, so this is nothing but a declaration that whatever I am going to define in this, they all have this common prefix. When I compile them, the class file which will be generated is not of the class which I write. Suppose I am saying, oh, this has a class called, let's say we are initially defining the class called rectangle. Okay, we are saying we have a class called rectangle. So what you are actually defining is a class called, yeah, when I compile this, what will be the output? The class file, what will be the name of the class file? What will be the name of the class file? Rectangle.class. Fine, it will be generating rectangle.class. Fine, but that class, what you have defined is not rectangle. What's the class which has been defined? com.classofjava.java1702.rectangle. That's a class which has been defined. If this has to be used anywhere, if this class has to be used anywhere, fine, it has to be. So if this is your rectangle class, and if someone is saying, oh, I want to write a class called test rectangle, okay, fine, in a different file, or that different file, it says I have a package. Let's not make a big package name, let's make it shorter now. Okay, fine, I have a package called simply test. I am writing classes for the purpose of testing. I have a package test, my prefix is test. So test dot this, test dot that, fine, I can have so many things. Okay, and I write a class called, which one? Test rectangle, okay. So we have test rectangle. So if you define this, okay, these two will have to be separate Java files altogether. They can't be in the same, because packet declaration is coming first, then the type definitions. Fine. So what is a packet declaration? It's a declaration. Package statement is simply a declaration of a prefix for anything being defined in this Java file. Fine. It's a prefix for whatever I am going to define in the Java file. Fine. A packet declaration can have multiple identifiers separated by dot. Fine. That's the case earlier, right? In this case, we have done that. com.classofjava.java1702 and put a semicolon. So package and, fine, you can have identifiers separated by dot and a semicolon. Convention is we use all lowercase for package. Your package components, fine, these are various components of your package name, they should be using lowercase. That's a convention. And syntax wise, yes, it's simply any Java identifier can be used. And but the convention followed is use lowercase letters. Fine. Fine, you know the convention for class names? Fine, begin with capital. Fine, start with capital. It is camel case, fine. Otherwise, if it's made up of multiple words, we don't use underscores. Fine, capitalize each starting. Fine, word start letter has to be capitalized. Fine, so follow those convention always. Fine. Okay, so now within the class test rectangle, I would like to use what? That one. How do I use it? I have a main method, and within main method, how do I declare? Yeah, it has to be written as com dot class of Java, sorry, dot rectangle. Sorry, this is Java 1702 dot rectangle, and then you can declare R1 comma R2, R1 R2 of this type. Fine. Data types, they have a prefix, fully qualified name. Clear? What is a packet declaration?
Like we had a same name of class name, then same name of class file created in the same folder.
Oh, where the things get created depends on how you compile.
Yes.
We have formed a habit of compiling with the switch called -d. If you use -d, fine, it's good. Fine. What it will do is it will organize. See, you can have two things with the same name. You will have two cuboid. Okay, let me make it shorter. Fine, fine. It's just to show that what conventions are followed. Convention is something to locate the originator of who has developed. Fine, fine, and within that, yes, if they are developing multiple things, fine. Okay, so there is a convention which is normally followed. Fine. For our case, yes, we may have a much shorter things here. Okay, fine. So maybe for our exercise, you could say we may have something like we can have packet declaration. So let's try like this. Let's have packages. Fine. Package means a prefix. Fine. There will be classes which have the same prefix. A number of classes which may have the common prefix. So they form part of a package. And so a particular package has so many classes. So there are so many classes which have the common prefix. Okay, fine. Now it's just it's just for convenience sake that someone says, oh, this is a sub package, and fine. There's no relation like sub package and a bigger package. Fine. There's no relation between them. They are independent packages. Fine. For example, someone says com.class of Java is one package. Of course, you can have some class which is defined with only this as the prefix com.class of Java, and there might be something which is com.class of Java.java 1701 or 1702. That becomes a prefix for someone else. You have a set of classes over there. Fine. Yeah, but
File created name of rectangle.class, and we have another file, and it also created rectangle.
Yes, so they can't exist in the same folder.
Yes.
So how do we organize them now? What's the natural way of organizing things now?
Make it another.
Huh? What folder? What folder? Because we understand how the names are going to become unique.
Package names.
So have a folder according to the package structure. Fine, fine, fine. You have folder being created when you compile your class file, right? If you use the -d option, if you don't use the -d option, it may create there itself. Fine, that class file may get created, but that's not the correct thing. Okay, so we got, fine, let's take a simple example now. Fine, so we might have a package, it's a package called, one is a package test. Okay, so we got package test in which you will have classes called test rectangle. You will have the test cuboid class. You will have the test account class. Okay, maybe there are 3 classes under this same prefix. Fine, that's one. Okay, then you can have another set of classes being defined which is going to have a common prefix. Let's say we have a package shapes, package shapes, which has rectangle and cuboid. Okay, and then you might have another package which is package shapes dot inheritance, INHER. I'm just keeping short name, and this again has a cuboid. Right. You have the account class, so that will have maybe a prefix called bank, package bank, and in this we should have a class called account. Okay, sorry, there's no semicolon here. So you have class called account. Fine. So you might use these kind of prefix to make the class identifiable, find more meaningful. Someone else can also say account for some other purpose, right? Not only bank account, there are accounts for some other purpose also, right? And we do accounting and there's account head, right? So clear? You would like to always have some meaningful prefix for your type names. Okay, and that is what we use with the help of package. Give a prefix to your type name. Okay, so when we compile anything, yeah, what is compiled? Fine, it's going to generate a class file, and the created class file. Remember this: whatever the class file which has been generated. Fine. So, for example, if there is an account class compiled which has a prefix of bank with the package bank, there are two things, right? You can create fine. Okay. Fine. So you have what? So when I compile this, let's say this is account.java I am compiling, which has package bank, right? When I compile this, I'll say Java C minus D. What's the destination? Where do I want it to go? In the bin folder. So I'll say /bin, and what's the file name? Account.java. When I compile this, what will happen? Class file, there will be this file called account.class. Where will it be? You will find in the bin folder a folder called bank being created, and that's a place where account.class will be generated. Right. You compile two, what will I do? I have got two cuboids. Oh. What do I do? They will have to be in separate Java files. What's the name of those Java files I'm going to use? Someone says, let me call this as cuboid 1, this is cuboid 2. Okay, since they are not public, you won't have problems. Fine, but when you compile, where will it go? Under bin, whatever is the destination, under that place, it will generate the folders according to your packet declaration, and then put the file under that. This is what the compiler is doing for us with the -d switch. Okay, use the -d. If you don't use -d, you'll get that class file right there itself. Huh? No, only with -d it generates folder. Fine. Otherwise, you'll have to put them in the appropriate folder, create the folder and put them. Fine. Oh, you already, without package also, you already have the class files, right? Why not we create the folder under bin and move the file there? Does it become a package? Does it become a package? The package is not because of the folder. Fine. It's not because of the folder that it becomes a package. Fine. The folder is again for another purpose. Let's see that. Okay. So when someone wants to use, we are giving, you recollect another thing which we were using when we were executing, we said Java, we used the -cp option. What is -cp? What is that cp here? What is cp? Class path. The path from where classes can be loaded, right? Okay. So now I'm saying my cp is, what should be my cp now? /bin. It's /bin. I'm asking it to load what? What it has to load?
Class.
Which class?
Account.
Oh no, there's no class called account. It is bank.account. You're asking it to load bank.account. There's nothing called account. It's bank.account which is being requested. Because you're asking for bank.account, it will look for wherever is the class path. From there, it will look for a folder bank and then it should find account.class. My class path is up to bin, not beyond. Whatever was my destination, same is the class path. Fine, because yes, it's from the bin itself. One folder is saying this is shapes where I have a cuboid. Another folder says it is shapes within which there is inheritance where cuboid is available. Fine, they are going to be, in bin we have shapes.cuboid, in bin we have shapes.inheritance.cuboid. They are all available from bin. They are loadable from bin. Fine. If it is, if that particular file which is compiled with a particular package declaration is not found in that kind of a folder, that class cannot be loaded. It becomes unloadable. That's the only thing. For it to be able to, for you to be able to load, right? By default, the loader would only load if it finds in the under class path, if it finds it in the folders matching your package structure. Fine. You are looking for shapes.cuboid. So a folder shapes and there cuboid.class. Fine. So class files have to be organized. Fine. Have to get organized like this. Fine. Simply moving already, you already have, you didn't use a packet declaration and you created your, you have compiled, you got some class files, and in bin folder you maybe create further folders and move those class files over there. Will it work? It won't work. Because when you say this is, when you have package bank and then this account, right? The class file which is generated, right? You know the class file, the content of the class file, in this it has its own name. And what is it stored for its name? What is the name he is storing? He is storing the name as bank.account. The name of the file is account.class, but inside that account.class, my name is bank.account. That's some information which is managed within the class file. So all class files, they manage their own names and they have their names within them. And what is the name? The prefix of package will always be there with them. Okay, and so just because of the directory structure, no, it's not that way, right? It's because of the package declaration that you get it to be like this. You get the prefix because of the packet declaration. Fine, so we find the compiler doing a smart thing for us and creating the folders to match the packet declaration, keeping the class files correctly for us so that they can be loaded from that same place. all the things can be loaded from that single place. Now, fine, that's compiler is looking after the class files, fine. That's the job of compiler. And who looks after the source code? We have to look after our source code. How would you like to organize your source code? You got 2 cuboids. How would you organize them? They of course will require 2 separate Java files because the package prefix is different. So how would you organize your Java files? You can't have cuboid.java, 2 cuboid.java in the same folder. You can only have one. So what do? Yeah. And you do exactly what the compiler is doing. Even for the source code, organize them properly. Put your Java files in the directory structure which matches your package. It's not compulsory. It's not compulsory, but it helps. And it will help, though it's not compulsory. Okay? Fine? You see, even if you have not organized it properly, but if you are able to show your dependencies while compiling, it's okay. Fine. See, with public classes, file name matching class name will be must. Fine, we understand. Yeah. Okay, I have been showing lot of code kind of things here. That yes, that okay, if you want to use in here, for example, in test rectangle, if you want, you will have to write the full name. That's what I said. But it would still not work here. Something which is not public would not be allowed to be used here. That class, if it was public, well, then I can use rectangle. If it was public, I can use it in test.test rectangle. Okay.
Sir, has a relationship the same?
Has a relation is?
Class must be public.
No, nothing about that. Class public things are independent of that. It's about accessibility. And who can access what? From where this, its classes are data types. This data type can be used from where? And that's something which you can specify. Yeah. And that's something which you can specify. Which class can be used from where? Okay. Okay, let me now come back to the structure of a Java file. Fine. So let's see what goes in a Java file now. First thing in a Java file, package declaration. I'm saying package. Let's say shapes. Fine, we have package shapes. Fine, then okay, fine, we understand, we can say okay, for the time being forget about the public or non-public things. We have yet to discuss that, but just ignore whether public or non-public thing. If you ignore that, let me talk of a different. I'm assuming we have shapes in which we have rectangle and cuboid. Fine. Okay, so let me create a separate package called test, in which you are defining the class called test rectangle or text cuboid. Fine, test cuboid, let's say. Fine. In this you are declaring, yeah, what do we declare? Shapes.rectangle. You'll say shapes.cuboid, shapes.rectangle everywhere. Everywhere I have to write the full name. Now another option which we have is, instead of writing the full name each and every place, you can make another declaration in this file. You can say there's a different statement. We have a statement called import. It's just a declaration. It's not like an include or anything like include. It's just a declaration for the compiler. It's just an instruction for the compiler. Fine. Okay, for example, I'll say import and I'll say shapes dot cuboid. Fine. When I do this, it's an instruction to the compiler that in this case, what's the last element in this? That's my last element. So I'm asking the compiler, if you come across cuboid, substitute with shapes dot cuboid. It's just a substitution rule for the compiler, so that I don't have to write full name everywhere. You're making a declaration once in this Java file. It's for the entire Java file, and this applies to the entire Java file. It's not about that this particular class itself. Okay, in this Java file, anywhere you come across cuboid, replace with shapes dot cuboid. That's the kind of thing you are trying to instruct. You are trying to instruct. That's what I'm just saying this. Okay, and you are trying to tell the compiler, if you come across cuboid, replace with shapes dot cuboid. So here maybe, fine, let's see what the compiler does. You tried to instruct it this way, right? But what the compiler does? When compiler comes across cuboid, what will it do? Will it make the substitution? Not necessarily. Not necessarily the substitution which you are specifying. Suppose it so happens that there's someone who has done a file like this. He has said, I've got a package test and I have a class called cuboid here also, which means test.cuboid is valid. Suppose there's a class cuboid in the package test. The compiler is compiling this code. It's coming across the token for cuboid. When it comes across the token cuboid, will it make the substitution? You have written an import. It won't make this substitution. What will be the substitution? Test.cuboid. First thing the compiler is looking for is, it assumes whatever you have not specified any prefix, it means whatever is unqualified, right, without a prefix, it means this must be for the current package. What is the package declaration? It must be for this only. That's its first try. Oh, I don't see it in the current one. Then let me check, is there any import which ends in this? Is there any import which ends in this? We have, fine, make that substitution. Clear? First priority, current package. Second one, import declaration. Fine, where we have fully qualified name. You have package test and a class cuboid? Yes, definitely. This will become test.cuboid in such a case. Oh, then how do you use shapes.cuboid? How do you use shapes.cuboid? The answer is there. Use shapes.cuboid. Fine. If you say cuboid, it will be test.cuboid. If you want to use shapes.cuboid, you'll have to write the full name. You can't have the shortcut. You have to write fully qualified name. First is the current package. Fine. Clear? Okay. Next thing, now we have another kind of an import declaration. Instead of saying import dot shapes dot cuboid, you have the option of using for the last element. If you have multiple things, for the last element, instead of writing a name, right, you can use a wildcard. You can use a asterisk star. Someone could have said import shapes dot star. Fine, it says import shapes dot star. So whenever it comes across any term, okay, any token where a data type is required, and it feels this must be a data type, okay, what it will do, check if this, which is unqualified, right, if this is belonging to the current package. Do we have like something like this in the current package? If we have, make that change. If it's not in the current package, look for import declarations which end in this. Fine. Oh, is there something which ends in this? Okay, there is one. Fine, I'll make the substitution. I don't have anything which ends in this. In that case, let's look at those imports which use a wildcard. Fine. And there, if I replace it, does it become valid? Instead of wildcard, if I put this, will it become valid? If it is becoming valid, I'll use it. Okay. Fine, let's see example. Now, give an example. I'll just use some of the things from the library, from the Java library. Okay. I'll just give some examples from Java library. Fine. So, in Java, whatever classes are there, all of them have a prefix. All of them have a prefix. Now what happens here is, any Java file, whether you mention or not, when the compiler always assumes that you got one import declaration. Import java.lang.star. This one import declaration is assumed by the compiler. You may not be writing this, but all Java files would be assumed to be having this by the compiler. Yeah. Okay, now let's have this is, let's say, packages test. Okay, we have a import declaration for java.sql.star. There's also another import declaration, java.util.star. Okay. Fine. First is sql.star and then is util.star. Somewhere in this we have date. Now it so happens that java.sql.date is valid and java.util.date is also valid. Yeah. So when it comes across date, fine. If someone has already got test.date, then there's no problem. It will immediately substitute. Here, when it comes across date, it says, okay, I don't find it in test. And let's assume we don't have anyone defining it in test. And then we don't have anyone ending in date. Do we have any declaration which says ends in date? If that was there, it wasn't a problem for it. Now what should it do? What's the substitution it should make? Huh? This would be a compilation error. It says this is ambiguous. I can't make out. Fine. So this is a compilation error, this scenario. Clear? Fine. If you wanted, you could have said import, and you prefer java.util.date over sql.date maybe. You could have done like this, so that other things from SQL and other things from util, fine, they are still usable without the fully qualified name. But yes, if I come across date, I'll substitute with java.util.date. If you want to use Java SQL date, you will have to write full name. Fine. Clear about the import declaration? And these are all declarative statements. Fine. What it means when I say declarative, this imports, there is no difference in the class file which is generated when you may be using import declarations, or you may not be using import declarations, which case it forces you to write the fully qualified names. So you have written fully qualified name everywhere, or you may have used import declarations. The output of class file will be same, generated class file. Fine. So this is not something which is executed like, okay, at when I execute at that time it is trying to get the things. No. When the things are compiled, the class file which is generated has everything fully qualified. Fine. The class file which is generated has every data type fully qualified. Fine. With all the prefix. Nowhere it's storing in shortcut. Okay. Fine. That's not that, oh, this has, I have to do import and then I'll be executing this. No. This is an instruction for the compiler, this import declaration for the compiler. When it is generating the output, the class file which is generated, it would use this. Okay. Okay. Now one thing, I already given a hint earlier also, that yes, this won't be working because public declarations. Public declarations. Ambiguity, we have understood the rules, right? When these import rules are okay now. Okay. Yeah. There's one more thing which I can, which is similar. We can finish that and then we'll go to the access specifiers. Fine. We have import declarations for data types. Fine. Because these types have unique names and they are uniquely identified. Package prefix dot their name. What about the static members? They also have a unique name or not? And they also have a unique name. So even when I am using some static member, okay, even for that I might use a import declaration. But then I have to, when I make an import declaration, I'll have to specify this import declaration is for the static type, fine, by using the prefix like this. Oops. So we have another kind of import which is known as static import, in which we use import followed by the keyword static, and then we write the fully qualified things. For example, we have something called, you want to use the value of pi, fine. Pi is a static variable, it's a static variable available in the class called math, but math is belonging to java.lang package. Okay, so I'll say import static java.lang.math.py. And so we have this thing called pi. So I can use pi anywhere. That's the last element. Fine. If I use pi, it is used as a static member. Fine. Static member anywhere. So we have imports available for static. Again, in both forms, either like this or with the wildcard also. Not for types, but for static members.
So math.star is valid.
Yes, math.star is valid. Fine. You can use dot star. Fine. So it has to be class name dot star. Okay, class name dot star if it is static. It can't be just package dot star with static. Okay, and nowhere you can say star dot star. Only for the last element you can put the wildcard. Yeah. Fine. Another thing here, because that's another question someone might have, is I have this one. I have a class called java.awt.image. Okay, so that's one class. Fine, I'm just writing a few class names, and I also have java.awt.package name lowercase I. Okay, this is lowercase I image dot buffered image. Okay, and I've written two class names. Okay, these are two class names which are valid. Now there is some Java file in which I am writing an import declaration which says import java.awt.star. Right? So what do you think works? Image works? Fine. Someone says, okay, I can use image, and someone says, oh, I might use image dot buffered image. Do you think this works? No, it doesn't work. Fine. Clear? This someone says this is a sub package of AWT. Java.awt is the package. This is a sub package. No, it's just for when we speak. It's in only in rough form, right? There's no relationship between those things. One import will not help the other import. They are two independent packages. They are two independent packages. Fine. Now before going for access specifiers, I think I should go for access specifiers, but then you'll have to remind me at least, because maybe I won't be able to cover the other thing which I should have taken earlier, the keyword final. I missed out the keyword final. Anyway, fine, so remind me next time, fine, if I don't cover it today. Fine, let's proceed with the things. Fine, so this is okay. Package, understood what is package? A packet declaration. We have understood the import declarations. Okay, now let's understand the access specifiers available in Java. Right. And the yeah. Okay, what are access specifiers for? Let's see this. If you look at the whole thing, the whole picture about Java, we got packages. Okay, let's assume these are packages, and packages in turn have classes and interfaces. What are the members of a package? Classes, interfaces, enum annotations, whatever we define. Okay, and classes in turn have members which are variables, methods, constructors, and those are the kind of members which go in a class definition. Okay, so what can be used from where? Classes, interfaces, enums, annotations are data types. Fine. So if you got something here which is part of this package, okay, you are writing another class over here. This is in a separate package. Fine. Can I use this data type? These are data types. Classes and interfaces, they are data types. Okay, for example, this is what? This is package P1. This is class C1, let's say. Can I use P1.C1 in anywhere in package P2? This is P2. Anywhere within this, when I'm, of course it has to be within a class or interface or whatever I'm writing. So within any of the classes here, can I use C1, P1.C1 rather? It depends on the access specifier for the class. Fine. A class can have, or I'll not say class, a member of a package can have only two access specifiers. They have only two access specifiers. One is they can be, fine, what it could be? Public or either they can be public or they can be nothing. Don't put anything. It has a meaning here. When you don't declare, okay, it's different from public. Either public or non-public. Or you call it as default. Fine. Okay. Or instead of default, you say this is package. Fine. It's a package access specifier. Okay. Fine. So if This is allowed for, so a class interface in a annotation which is going to be a member of a package can have only two possible access specifiers. Either they are public or they are non-public. Okay. If it is non-public, then that data type is not usable outside the package. It's not available outside the package. Outside the package, it's not known. Okay. So if someone tries from here p1.c1, not available. Within this, anywhere, yes, p1.c1 or simply c1 would also mean p1.c1. Default is the current package. For anything which is having a package prefix of p1, right? Within that definition, if they try to use p1.c1, yes, it's available. And so scope is the package. And that's about the types. Okay. Fine. You can have, we'll see about it later, but fine. So this is one. Okay. For members of package, two access specifiers. For members of an interface or a annotation, because annotation similar to a interface. For members of an interface or an annotation, all members, whether you declare them or not, are always public. Right? They are always public. Members of interface and annotation, always public. You may not have mentioned public, it would be still considered to be public.
So interface member, interface itself is public.
No, members of the interface. Now we are going to members. We've seen member of a package. Now we are seeing member of interface. And then let's see member of class. We know what members go in a class definition. Fine. For members of class, there are 4 access specifiers. Fine. Any member of a class can have 4 access specifiers. Okay. What are the 4 access specifiers? The most restrictive one is the private. Member of a class can be private. If a member is declared as private, it would mean it's available within the class only. Outside the class, it is not known. Fine, it's not known outside the class. Fine, for example, in rectangle, we might make length and width to be private. Fine. So in the other place, he can't say r1.length then. Fine, it's not in the same class. Fine, it's outside the class, so you can't access. Okay, so private is class level. Next one, blank. If you don't give, fine. So if something here is private, right, the accessibility is the class. If something here is default, the accessibility is the package. In this package, any class can use it. Outside the package, no, it's not known. Fine, default ones, fine, we call them as package access. Default means package access. And they are not available outside the package. Okay. See one thing, even about inheritance, what do you think? Private members, they get inherited? No. And they are not inherited. Default members? Inherited if it is within the package. The subclass is in the package, yes, it is inherited. If the subclass happens to be outside the package, here is a subclass inheriting from here. The default members are not inherited. Fine. The default members, anyway, not accessible, not inherited. Okay, now comes the third level. And these are levels basically. First level private, second level default, third level is protected. You declare something to be protected, what would it mean? Is it accessible outside the package? No.
in the subclass.
It is not accessible anywhere outside the package. It is exactly like default. Only small, very slight difference. It gets inherited outside the package. It can be inherited in the subclass outside the package. Fine, I'm saying it's not accessible, but it is inherited. Not accessible, but inheritable. Okay, fine, let's understand this difference. Okay, let me assume we have a variable x here which is protected. X in C1 is a protected member. The class C1 is a public class. Okay, because the class C1 is a public class, it can be used and you can create a subclass even outside the package. Fine, if it was not public, you couldn't have a subclass outside the package. Fine, so the class is public and we have a class C2 here, okay, which is a subclass of C1. Fine, but C2 is in P2. Okay, fine. Now, in C2, it has a declaration. It declares that I have something of type C1, P1.C1. I have some object, let's say C. C is one object. And he says, I would like to use C.X. What do you think?
If it's protected, then
Yeah, it is protected. X is protected. Not valid. It's not accessible. X is not accessible. Okay, a protected variable is not accessible. It is inherited. It gets inherited, which would mean that here within this class, if I simply say this dot x, it's available. If I use super dot x, that's also available to me. Even super dot x would be available
through object determinants.
on my current object. I have inherited, I have it on my object. I have it in this object. I can't access on an object which is of the super type. I have inherited it. I don't have access to it. I have inherited, whatever is inherited, yes, I can use that. I can use the inherited, but not on a different object. Fine. On the current object, yes, I can.
The all protected members will be inherited.
Yes, protected members get inherited even outside the package. That's the only difference. Otherwise, accessibility wise, similar to default. Fine. Protected is always available within throughout the package. See, this is different from the protected of C++. Be careful, okay? I don't have a subclass here. This is not a subclass, but it can access X because it is part of the package.
So protected member is a class level. Class level protected members.
Protected in a particular, it's a member of a class which you can have as a protected member. You have declared some variable X maybe to be a protected variable. Yeah.
So the inherited class in the same package then.
In the same, no, if it is same package, there's no restriction. See one thing, these access specifiers which are being specified here, they are a hierarchy. Fine. If I can access whatever that place may be, if I can access the private member, we understand where it can be accessed. For a particular class, I can access all others. If I can access default, maybe I may or may not be able to access private. I'm able to access default would mean I can access default, protected and public. If I can access protected, it would mean I can access protected and public. When this is a narrower access, this is a wider access. It goes like this. Last one is public. And they have a hierarchy like this. Narrow access to a broader access. Narrowest is public and broadest is public. Sorry, narrowest is private, broadest is public. Sorry. Yeah.
So C2 class is in a package P1.
Is in P1?
Both are
Yeah.
in P1.
Yeah. If they are part of the same package, there's no problem.
Protective we can use.
We can use because protected is after this. Can we use this? If it is in same package, we can use this or not? No?
Yes.
If it is same package, we can use.
So private is a class level.
Not private, I am talking about this default.
Okay. Default, yeah.
If default can be used, protected is definitely usable. And that's what the hierarchy is. If I have access to default, I can have access to protected and public as well. Fine. And public members accessible everywhere. Fine. The 4 access specifiers. Okay. Now one thing is about, this is related to inheritance. Right? Something related to inheritance rule about overriding method. And we have a rule about the overriding method. You have a superclass and we have a, we have a subclass of a superclass. You got some method M1 over here. Okay. Fine, method signature, everything is same. I am overriding the method M1 here. Okay, now let's assume this M1 is a default. Let's say it is default. Or yeah, it's default here in class C1 and this is class C2. C2 is a subclass of C1. C2 is a subclass of C1. When C2 overrides, what access specifiers can I use? Okay, instead of default, let me assume protected. So this is protected in C1. M1 is protected in C1. I want to override this method. What access specifiers would be allowed? Definitely I can keep it protected. What access specifiers should be allowed? Can I make it default?
Yes.
It's protected here. Here, can I make it default?
Yes.
Okay. Which would mean C2 is a subclass. So there was some feature available in the superclass, but the subclass doesn't allow that. Inheritance. What does inheritance say? If something works on supertype, it definitely works here. You can have more functionality. You can't reduce functionality in a subclass. And you can't be reducing functionality in a subclass. And therefore, you cannot have a weaker access. Overriding methods cannot use a weaker access. We understand what is weaker access? Which is weaker? Private. Fine. Then comes default, then comes protected, and then comes public. So if something is protected, it can be kept protected or it can be made public. You can't reduce, you can't narrow the accessibility. Fine, you can keep the same accessibility or you can make it wider. Clear? Overriding method. Rule about the overriding method. Fine. So, fine. Now you should be clear about the package, the import, and the access specifiers. Fine. There's some slightly another access specifier related issue, but that we can take up later when we look at the nested types. Fine. Can we have a private class? See, for members of a package, only 2 access specifiers. But I am saying we can have a private class. What would it mean?
Should be the inner class.
Fine. So we have class as a member of a class also possibility. Fine. Which we haven't seen. Okay. Fine. So when we look at that, fine, we can look at that. Have a rule even at the access specifiers. Especially it's a private access specifier which I would like to make the meaning clear here. Okay, let me clarify the private access specifier further. Okay, fine. You got a class A, it's a class, okay, a part of some package, fine, which has nested classes B and C. There is a class A having nested classes B and C. A has a private member X, B has a private member Y, C has a private member Z. Okay, so what about X? X is available in A, what about in B?
Yes.
What about in C?
Yes.
Yes. Y?
Only
Available in?
private.
Available in A also. Not only A, it is accessible even in C. Of course, you need one object of B. If you have an object of B on which Y is available, yes, you can be, there is no access restriction here. Fine. The private works as private for the member of the package. This is the member of the package. And there is some package to which it belongs. See, when you don't make a package declaration, still it is part of a package. There is a package called the unnamed package. Okay, you have the unnamed package. Okay, so when you don't make a package declaration, they are all belonging to the unnamed package. Okay, so that way, so everything is part of a package anyway. So now, when someone says private, fine, we look at private as, so Y and Z are private, but they are private to whom? To A. They are private to A because A is the member of package. Who is the member of package? B and C are not members of package. They are member of A. The member of B and C, which are private, are member of A. So it is private to A. Y and Z are also private to A.
So what is the meaning of like a private keyword?
Yeah. Why? If it is private, it's not accessible to this one. It's not accessible to D.
So if X is private, Y and Z are public, then
Y and Z are public. They are public to all.
everywhere.
Yes.
It's a part of the private class.
Class is private. You are saying X is private.
X is private, X variable, and Y and Z are public variables.
But X is part of A. What about A? The class A
Is a public.
is default or public?
Yes.
Clear? See, every member has its own access specifier. Fine, it's not, oh, my class is public and therefore the members become public. Nothing like that, okay? And everyone has its own access specifiers. This class represents a type. The type can be used or not, that will be decided by the access specifier of the type. Fine. That variable can be used or not is decided by the access specifier of the variable. Fine. Can I use new and create an object is decided by the access specifier for the constructor. We use new with the constructor. So that constructor is private. Oh, then I can't use new. Is that constructor default? Access specifier. Fine. So we have access specifier for variables, methods, constructors. And normally for variables, we keep private access specifier. And in case of static constants, we haven't seen constants. You might be keeping variables also as public. And okay, but then they are something which are unmodifiable then. Okay, fine. We still have to look at how do we create something which is unmodifiable. Fine. Fine, clear on access specifiers. Package thing, import. Okay. The exercise would be yeah, we haven't done the exercise related to inheritance for the account class. That also has to be done, right? Okay, so a lot of exercises now. But then the big exercise is we want two versions of cuboid. One using inheritance, the other using composition. And we would like to have package. Put everything in package now onwards. Okay. Fine. So the classes, whatever classes we have seen so far, like string is not string. It is java.lang.string. Fine. We don't have anything called system. It is java.lang.system. Yeah, one more thing. which is related. You have generated Java doc?
Yes.
Okay. Now when you generate documentation, when you generate it for whom?
Other.
For other programmers? Okay. How the other programmers are going to be able to use your class? Are they able to use the private variable of your class? No. Are they able to use the default variables of your class? No. The protected and the public ones, right?
Yes.
And therefore, when we say Java doc, recollect this. Recollect now? When we gave Java doc and you tried where we didn't have a public member, it said, no, I can't generate a documentation. By default, it will generate documentation only for protected and public members. Fine. When you have all four switches, you can say generate documentation which only includes public. So you can say Java doc minus public. Fine. One switch is minus public. So only document related to public members. Fine. But then you could also say minus protected. Minus protected would mean documentation related to
Protected and public.
yes, fine, protected and public both. Or you could say minus, what we had used was, when we had used this minus package,
For all.
not for all,
Default.
for default, protected and public. Default, protected and public. Fine, you can say minus package. If I say minus private, yes, that is the full thing. Fine. For example, you might use this for distribution to most of the people. You might be generating documentation for your teammates who also contribute to the same package. Fine. If you want to share a documentation with your teammates who are contributing in the same package, you will have the minus package prefix. And you want to generate a documentation for someone who is going to maintain this code after you have left. Okay, fine. You have to generate a private documentation. So everything is there. Fine. So what level of documentation you want to generate? That can be controlled with this. Fine. So fine. Earlier we had actually been using this because at that time we didn't use a package prefix. And we didn't have a public member. And the class, we didn't create public class at all at that time, right? But, clear? And then we have, now what we have for the entire Java library, there is this kind of a documentation available, but that is this one, okay? It's this one. This level of documentation is available to us as part of the documentation which you receive. And there is a separate download for documentation for JDK. Okay, so as part of that, there is a folder for API where you will find index.html, and that has full documentation for all the Java library. Find package wise, find a different thing. So if you want, I can just try to show a bit of that documentation, how it looks like, because now it arranges them in a different way. That's how the documentation appears. Okay, here is the package list. Fine, last time when you now if you generate documentation after the package, your thing is also going to look similarly with 3 frames. 1 frame for package list. Okay, fine. So for example, here you have java.lang. So click here, get the classes, interfaces, the various kinds of things there. Math, okay, math, that's here. And then the various members, you can go directly for the fields, E and pi. Those are there as constants. And then you have all static methods here. Fine. So math dot absolute, you get the absolute value. And so like this. And you can go into the details. And this is all from this is like Java doc. Now, if you look at this you can relate to the Java doc which they have in the Java file. You have your source code files, you have the source code for Java, all these library classes, whatever documentation you are seeing, fine. For them, the Java source code is available for all these classes. When you install JDK, there is one src.zip file also which is copied there. Fine. So create one folder and extract it over there. Fine. You'll find the subfolders according to the package being generated and the Java files residing over there. And so you have all these as Java files also, and you should be able to relate this to the documentation comment which goes there. Fine. So they have written a lot of documentation here. You'll find there's more of comment and less of code. There are more comments than code. Fine, most of the places. Okay, fine. So tomorrow, yeah. One thing I'll have to talk about final tomorrow, and then we should have practice. Fine. अच्छा आज रिकॉर्डिंग किया नहीं किया? हाँ किया.